Welcome to SAT Papers Solution, and we are going to discuss Physics paper number 9. In this paper some questions are missing, so we'll start with question number 7. So there is a diagram given for question 7 to 9. In this diagram a process is given between pressure and volume. Okay. So first is, which of the following processes are isothermal? So the basic property of isothermal process is, when system interacts with any external reservoir, it means whenever it will accept some heat from external reservoir or it will deliver some heat to external reservoir, at that time your temperature of process will be constant and process called isothermal process. So for question number 7, process 1 to 2 and 3 to 4 will be isothermal process. So option D will be right choice. Now next is, which of the following process is adiabatic process? So in case of adiabatic process, there will be expansion in volume without any additional external heat. It will be due to internal energy of the system. So the process 1 to 2 and 3 to 4, it is interacting with some external system. So there is exchange of heat. Process 4 to 1, in this case volume is shrinking. So the adiabatic process will be process 2 to 3. So option B will be correct in this case. Now coming to question number 9. Is the amount of energy exchanged between a system and a hot reservoir at temperature 1000 Kelvin is 100 kilojoule, and system releases energy to a cold reservoir at temperature 600 Kelvin. How much work done to the outside? So it will draw the system. So there is one reservoir at 1000 Kelvin and it is providing energy QH is equals to 100 kilojoule to this system, and then system interacting with a cold reservoir at 600 degree Kelvin. Suppose here energy is QC. Okay. So for any closed system, we can say the total entropy S should be 0. Okay. So we can write this expression as QH over TH plus QC over TC must be equals to 0. So QH is 100 kilojoule, TH is 1000. QC needs to be calculated and TC is 600. So from here we can calculate QC, that system is delivering to a cool reservoir, that will be 100 divided by 1000 multiplied by 600. So we'll get 60 kilojoule. So the remaining energy will be work done to outside world. So work done will be 100 kilojoule minus 60 kilojoule and it will be 40 kilojoule. Here is some misprinting, but the correct option will be 40 kilojoule. Now moving to next question, question number 10. That a ball with mass m on a string of length r swinging around in a circular motion at its instantaneous velocity v and centripetal acceleration is a. So we can establish a relationship, that is centripetal acceleration is v square over r, because centripetal force works on this ball will be mv square over r. So if we divide by mass, then we'll get v square over r. So question is, what is the centripetal acceleration of ball if length of a string is doubled? So if we'll change this r to 2r, then acceleration will get half of the initial acceleration. So option B will be correct for question number 10. Now the next question is, what is acceleration centripetal of the ball if instantaneous velocity of ball is doubled? So if we'll change v to 2v in this equation, so we'll get acceleration is 4v square r. So new acceleration will be 4 times of initial. So in this question, option number E will be correct.